Good evening. Today we are going to see about two important systems of classification such as pharmacological classification and taxonomical classification. These two classifications are very complex and it has many subcategories, and hence it's generally very complex and tough to understand. Let we see steadily one by one. Pharmacological classification. It's based on the principle that here we are going to classify all the crude drugs based on its pharmacological action. So based on what's a pharmacological action a particular crude drug is giving, we are going to classify it, right? So here there will be much more subcategories, and each subcategory denotes a system in our body. So the crude drugs which are acting on urinary system will come as a subcategory. Those which are acting on our nervous system will come as a subcategory. Those which are acting on our cardiovascular system will come as a subcategory. Those which are acting on our respiratory system will come as a subcategory. Like that it will go on, right? So in pharmacological classification there will be many subcategories, and each subcategory denotes a particular system in our body. So let we see the examples one by one so that we could able to understand very easily. So first category, drugs acting on our gastrointestinal tract, right? And again in this category there will be many subtypes. Why means in gastrointestinal tract we may get many disease or disorders. For example, we may get constipation or diarrhea or else indigestion, or like that, so on. And for each disease we are going to have certain crude drugs, right? So that in this category again there will be many subtypes. So the drugs acting on gastrointestinal tract has here four subtypes. We are just going to see only four. There are much more, but let we see two or three examples in each subcategory so that it won't be much confusing, right? So number one, carminative. So carminative means those drugs which eases digestion by relieving gases from our stomach will be called as carminative. And the best example is cardamom, or else we can say all volatile oil containing drugs can be used as carminative. And next category, emetic, drugs that induces vomiting. Example, ipecac. Number 3, laxative, drugs that relieves constipation. And example, agar. And last category, purgative, again this is also going to ease out constipation. Example, castor oil. But based on the mechanism of action, laxative drugs are different, whereas purgative are different. Both are going to relieve constipation, but they are going to act on different way, so that we had classified separately. Okay, so these are about gastrointestinal tract drugs. It's second category, drugs acting on our cardiovascular system. And below that we are going to see three subcategories. Number one, cardiotonic, drugs that tonicize, means which nourishes our heart, are called cardiotonic, and the best example is digitalis purpurea, right? And second, antihypertensive agents. So the drugs, the crude drugs which are going to reduce hypertension are antihypertensives, and the best example, as we all know, ravolpium. Third category, cardiac depression. Drugs that are going to suppress or depress the function or action of our heart are called as cardiac depression. And the example, Syncona. Now, the third category in this pharmacological system of classification, drugs acting on our central nervous system. And below this category, again we are going to see about three classes. Number one, cardiac stimulant. Number two, CNS depressant. Number three, central analgesic. The first category, cardiac stimulant. I'm sorry that it has been typed or wrongly. Actually, it is CNS stimulant, right? Drugs that are going to stimulate our nervous system are called as CNS stimulant. And the example, best example, tea or coffee. Caffeine present in that particular tea will be stimulating our nervous system. So due to which only we are drinking a cup of tea early in the morning, right? Okay. And second category, CNS depressant. Drugs that are going to depress our nervous system. An example, opium. And third category, central analgesics. Drugs that can be used as central analgesic, means to relieve central pain. And example, opium. And fourth category, drugs acting on our respiratory system. And again there are three subclass below that. Number one, expectorant. So drugs which are going to or which expels the sputum present in our respiratory tract will be called as expectorant, and example is licorice. Number two, antitussive. Drugs that suppresses cough or that reduces cough or that relieves cough will be called as antitussive. Example, opium. Codeine present in that codeine present in opium is used as antitussive. And three, bronchodilator. Drugs that are going to dilate the bronchus or that are going to relieve bronchospasm are called as bronchodilator. Example, tea. Right? So like this, for each system in our body there will be a subclass. Okay, it will be going on like that. Right. And what is the advantage, what is the merit of studying this pharmacological system of classification? So it can be used to suggest substituent drugs. Substituent drug. It can be used to suggest substituent drug. For example, I am searching for a crude drug that can be used as laxative. Okay, so I am searching for a crude drug which can be used as laxative. So we all know agar can be used as a laxative. So I am searching for agar, but nearby market does not have agar. Now what I can do for it? So if I go through this pharmacological system of classification, and here if it shows second drug, so that if there is any other drug like let me take senna, which can be used as laxative. So by seeing this pharmacological system of classification, I can go for the second drug, and if it is available in the market, then I can get it easily, right? So pharmacological system of classification suggests substituent drugs. Okay, what's the disadvantage of this classification? Drugs with two different pharmacological action will get repeated, right? For example, a crude drug can be used as cardiotonic, again which can be used as diuretic. Let me check. So it has function on heart as well as kidney. So now we will be having confusion whether we have to place this crude drug in CVS or else in urinary system. So that will be the problem. If it has two pharmacological action, then it will get repeated, or else there will be a confusion how to place it, right? And the book which is following this pharmacological system of classification is Textbook of Pharmacognosy by Henda and Kapoor. Famous book, Textbook of Pharmacognosy by Henda and Kapoor. Right, that's about pharmacological system of classification. Now we are entering into taxonomical system of classification. Taxonomical classification, which can be also called as biological classification or botanical classification. Oh, it's one of a famous classification, right? By using this classification only, plant got two names, a genus name and a species name. Binomial nomenclature came to our world through this classification only. So that we can say that it's a very famous system of classification, taxonomical classification. It can be also called as biological classification. Actually, taxonomical classification is not followed by pharmacist in general. It's followed by botanist. Because we won't study botanical characters that much deeply, whereas botanist will be doing it, so that we won't be following the taxonomical classification in general. But let me know what is meant by that. Okay, it is complex and it is an advanced system of classification, because till now what we had seen, for example, alphabetical or chemical or else pharmacological, in each system of classification we will be having only one criteria, and based on that particular criteria we are going to classify all the crude drugs. Whereas here in taxonomical system of classification, we are going to have more than 5 to 10 characters, more than 5 characters, and we are going to classify the crude drug. So that it's a complex and advanced method of classifying crude drug, right? Here it is based upon the natural relationship among the plants. So here we are going to categorize the crude drug based on the relationship between each and every one. Okay, for example, let me take, if 10 plants have same shape, leaf shape, let me consider 10 plants is having similar leaf structure or leaf pattern or else shape, then we will be keeping it in a single group. Okay, if 10 plants have same number of petals or sepals in its flower, then we will be grouping it separately. So here like that, based on the morphological character, let me take, based on the morphological characters or else based on the similarity between each and every plant, we are going to categorize it. Okay, here the categorization of each and every plant will be done by these many characters, by these many subtypes. Okay, which can be kingdom, phylum, division, then class, followed by order, family, genus, and then species, right? So there will be a kingdom which will be again classified into many phyla, again classified into many division, which will be classified into many class, and each class contain many order, and each order contains many families, and each family contains many genus, and each plant in that particular genus gets a species name. Or let me see it with one example so that we could able to understand it very easily. Here I am going to explain about the plant licorice. So they are categorized it likewise. Uh, Licorice belong to kingdom Plantae, phylum Spermatophyta, division Angiospermae, class Dicotyledon, order Rosales, family Leguminosae, genus Glycyrrhiza, and species Glabra. So I will explain, I will tell the meaning of each and everything so that we could able to sort it out, we can able to understand it easily. Kingdom Plantae. So all the plants will be coming under one kingdom. All animals may be coming into one kingdom. All insects may be grouped into one kingdom. Okay. So here all plants has been in a kingdom called as Plantae. Next, phylum Spermatophyta. Now the Plantae kingdom is categorized into many phyla. and one of that particular phyla is Spermatophyta. Spermatophyta means plants that bears seeds are called Spermatophyta. Okay, so plants that has seeds that germinates by using that seeds will be called as Spermatophyta. Right? So we may know that there are many plants which does not bear seeds. Some may bear spores. Right? So plants that has seeds will be coming into this Spermatophyta phylum. Plants that does not have seeds will be going into some other phyla. Now seed bearing plants coming into this phyla. Again, this phylum is divided into many divisions. Our plant licorice is placed in Angiospermae division. So Angiospermae means flower bearing plants. Okay. So flower bearing plants will be kept under Angiospermae division, whereas non-flowering plants will be kept under Gymnospermae division. So since our plant licorice is a seed bearing plant, is a flowering plant, we are kept under Spermatophyta phylum and Angiospermae division. Now again, there are many classes. Licorice is coming under Dicotyledon class. Okay, so di means two. Cotyledon means actually when a seed is getting germinated, some leaf-like structure will be coming out. We may be seen. Uh, and some seeds bear one leaf structure and some may have two leafed. That particular leaf structure will be called as cotyledon. So when the seed is getting germinated and if it shows two cotyledons, then that particular plant will be called as dicotyledon. If it has only one cotyledon, that will be called as monocot. So our plant licorice bears two cotyledons, so we kept it under dicotyledon class. Okay. Now order, row cells. So row cells, as the name indicates, here the plant bears flower like a rose. So already we had told in division itself, it's an angiosperm plant, which means it bears flower. So this flower will look like a rose, so that we had kept it under row cells order, and that is followed by family. Oh, licorice belongs to family called as Leguminosae. So Leguminosae word indicates that if a plant bears legume type of fruit, that will be coming under Leguminosae. Legumes, example, simple example, beans. Okay, so our plant licorice has legume kind of fruit, so that we had kept it under Leguminosae family. Now the genus name is Glycyrrhiza and the exact species name is glabra. So we can say that our plant licorice is a seed bearing plant, is a flowering plant. While germinating, it shows two cotyledon. It has rose like flower and its fruits are looks like legumes. Right, so by having these many informations only, we can able to classify each and every crude drug. So that only in the beginning I had told that taxonomical system of classification is a complex system of classification. Right, I think you may understood. And the advantage, what's the merit of this taxonomical classification? It gives enormous information about the nature of the plant. We may seen it from the explanation about licorice itself. It gives that many information about each and every plant. That's a big advantage of this taxonomical classification. Demerit, it's very difficult to identify a crude drug and it does not taken the chemical constituents into its account. So if you want to identify, if you want to see or check a crude drug, it's very difficult and time taking process to identify it, since we will be going through many steps. It's very difficult. And number two, here it does not take on the chemical constituents to classify the crude drugs. Those two are the disadvantage of this taxonomical system of classification. So that's it for today. Tomorrow we will see with some other topic. Thank you.